Australia's ancient past has revealed a truly spectacular creature. This creature is a giant flying reptile called a pterosaur. Scientists have named it. It soared through the skies long ago, during the time of dinosaurs. This was over 100 million years ago, in the Cretaceous period. Finding such a large pterosaur in Australia is very exciting news. It tells us more about the diverse life that once existed on this continent. This discovery helps paint a clearer picture of Australia's prehistoric world. Holds a special place in Australian science. It is officially the largest pterosaur ever found in the country. Imagine a creature with a wingspan as wide as a small aeroplane. This pterosaur was a true giant of its time. Its discovery adds a significant piece to the puzzle of ancient Australian ecosystems. Before this find, evidence for very large pterosaurs in Australia was quite limited. Now we know that these magnificent flying reptiles were indeed present. They were an important part of the prehistoric landscape, casting large shadows as they flew overhead. The name is very meaningful. It comes from the Wunamara First Nations language. The Wunamara people are the traditional custodians of the land where the fossil was found. Thapun means spear, and Ngaka means mouth, so translates to spear mouth. This name perfectly describes the pterosaur's long pointed snout. The second part of the name, Shawi, honors the person who discovered the fossil. This was Mr. Len Shaw, a local fossicker. He found the crucial bone fragment in 2011. Naming it this way respects both scientific tradition and Indigenous heritage. The discovery happened in a remote part of Queensland. Len Shaw was searching for fossils near Richmond. This area is famous for its marine reptile fossils from the Cretaceous period. He stumbled upon a piece of bone that looked unusual. It was a fragment of a lower jaw, specifically the front part, called the mandibular symphysis. Mr. Shaw recognized that it might be important. He donated the fossil to the Kronosaurus Corner Museum in Richmond. Scientists from the University of Queensland, led by Tim Richards, studied the fossil. They carefully examined its features. They compared it to other pterosaur fossils from around the world. It became clear that this jaw fragment belonged to a very large pterosaur. It was also distinct enough to be considered a new species and genus. The research confirmed that it was the largest pterosaur known from Australia. Was an impressively large animal. Scientists estimate its wingspan was around 7 meters, or about 23 feet. This is similar to the wingspan of a small glider plane. Imagine a creature of this size soaring through the air. It would have been a truly awe-inspiring sight. While not the largest pterosaur ever found globally, it was certainly a giant. For Australia, it represents the biggest flying reptile discovered to date. This size made it a formidable predator in its ecosystem. Its large wings allowed it to cover vast distances over the ancient Eromanga Sea. The most distinctive feature known from the fossil, is its skull. The name spearmouth refers to its long, narrow snout. This snout was likely over 1 meter long. It was filled with sharp, spike-like teeth. These teeth were perfectly designed for catching and holding slippery prey such as fish. The jaw fragment found by Len Shaw shows large tooth sockets. These sockets indicate the presence of substantial teeth at the front of the jaw. The front of the lower jaw was fused, forming a strong, spear-like tip. This unique skull structure is characteristic of the Anhangarian group of pterosaurs. Pterosaurs, despite their large size, had very lightweight bones. Was a skilled predator. Its primary food source was likely fish. The ancient Eromanga Sea, which covered much of Queensland, was rich in marine life. This provided an abundant food supply for a large flying hunter. Probably soared high above the water, using its keen eyesight to spot fish near the surface. Once prey was located, it would swoop down. It would use its long, spear-like snout and sharp teeth to snatch fish from the water. This hunting technique is similar to that proposed for other related pterosaurs found in different parts of the world. The lifestyle involved spending a lot of time in the air. Its large wings were adapted for soaring, allowing it to cover long distances with minimal effort. This was useful for searching for food over the vast expanse of the Eromanga Sea. It may have also been capable of strong, flapping flight when needed, such as during takeoff or when pursuing prey. On the ground, Pterosaurs were likely a bit awkward. They walked on all fours, using their folded wings as front limbs. However, they were probably most comfortable and efficient when airborne. Section 5. A place in the pterosaur family. Classification and evolutionary significance. Belongs to a group of pterosaurs called Anhangarians. This group is part of a larger lineage known as ornithocerids, or more broadly, pteranodontoids. Anhangarians are characterized by their long snouts, often with rounded bony crests at the front of the upper and lower jaws. They also typically had large teeth concentrated at the tips of their jaws. These features made them specialized fish eaters. The discovery of confirms that Anhangarians had a global distribution, including Australia. This is significant for understanding their evolutionary success during the Cretaceous period. Anhangarian pterosaurs are best known from fossils found in Brazil, particularly from the Romualdo Formation. Famous examples include Section 6. Shifting perspectives. The scientific impact of Australia's largest pterosaur. The discovery of has significantly changed our understanding of Australian prehistory. It provides concrete evidence of giant pterosaurs inhabiting the continent. For a long time, it was thought that Australia might have lacked these very large flying reptiles, or that they were extremely rare. This find challenges those assumptions. It shows that Australia's ancient ecosystems were more diverse and complex than previously appreciated. It adds a new apex predator to the skies of Cretaceous Australia. This helps scientists build a more complete picture of life during that time. This pterosaur also makes a vital contribution to global pterosaur research. Every new pterosaur discovery, especially of a large and distinct form adds valuable data. It helps paleontologists understand the patterns of pterosaur evolution, their geographical spread, and their eventual extinction. Section 7. Beyond the bones, cultural recognition and indigenous heritage. The naming of carries deep cultural significance. The researchers chose to incorporate language from the Wanamara First Nations people. This was done in consultation and with the support of Wanamara representatives. Using Thapunngaka, meaning spearmouth, directly connects the scientific discovery to the traditional custodians of the land where the fossil was found. This act of naming is a powerful way to acknowledge and respect Indigenous heritage. It recognizes the long history and deep connection of Aboriginal and Torres Strait Islander peoples to the Australian continent. This collaboration between scientists and Indigenous communities is increasingly important. It fosters mutual respect and understanding. By involving First Nations people in the naming process, science can become more inclusive. It acknowledges that these lands have stories and histories that predate European settlement by tens of thousands of years. Section 8. Lingering mysteries, unanswered questions and future research avenues. Despite the excitement surrounding, many questions remain unanswered. The current understanding of this pterosaur is based on a single fragment of its lower jaw. This means we don't know what the rest of its skeleton looked like. How large were its upper jaw crests? What was the exact shape of its wings? How did it move on land? These are just some of the anatomical details that are still a mystery. Discovering more complete skeletal remains is crucial to fully reconstruct this magnificent creature and understand its biology in greater detail. Another area for future research is its precise diet and ecological role. While it is presumed to be a fish eater, like other Anhangarians, direct evidence is lacking. Section 9. The enduring legacy of the sky dragon. Concluding thoughts. Australia's spearmouth sky dragon has left an indelible mark on science. Its discovery has reshaped our understanding of prehistoric life on the continent. It stands as a testament to the incredible creatures that once roamed Australian skies. This giant pterosaur was a formidable predator, perfectly adapted to its marine environment. The identification from a single jaw fragment showcases the power of careful scientific study. It reminds us that even small pieces of the past can tell grand stories about ancient worlds and their inhabitants. The legacy of extends beyond scientific journals and museum displays. It has the power to inspire awe and curiosity in people of all ages. Stories of giant flying reptiles capture the imagination. They can encourage young people to learn more about science, paleontology, and the history of our planet. This particular discovery, with its connection to Indigenous culture through its name, also promotes a deeper appreciation for Australia's rich heritage.